Okay, so welcome back, and now let's do a couple of examples here. So the first example, we're given two vectors in standard position, right? And so now, how do we do this? We want to find the dot product of these two. Okay, so let's do that. So we're going to do u dot v. Okay, now what are we going to do? We're going to take the product of the corresponding coordinates and then add those together. So it's going to be 5 times -3 plus 12 times 4. And so if we do that, we get -15 plus 48, which is going to equal 33. And so the dot product of u dot v, or the dot product of u and v, is 33. Okay, and remember, we should always get a scalar. Okay, now, well, what about this one? So now this is given in rectangular form, right? So ij form. So how do we do this? Well, the only thing you have to remember is, if it's in ij form, v1 is equal to what? 5, 2. And v2 is equal to 3, 7. And now, if you see that, then if you understand that, then it's very straightforward. It's the same thing. So if I want the dot product of v1 dot v2, then I'm going to just do the same thing. So it's going to be 5 times 3 plus 2 times 7. And so the dot product of v1 and v2 is going to equal 15 plus 14, which equals 29. Okay, now, so we're not done. Now in this problem, they ask us to find the angle between them. So let's do that. Okay, now, let me erase this. And so now what I'm going to do is I'm going to use the formula cosine theta equals v1 over the magnitude of v1 dot product with v2 over the magnitude of v2. So now, first of all, we need to find the magnitude of v1 and v2. Well, the magnitude of v1, we're just going to use the formula, right? We've got the corresponding vector notation, right? The position, standard position. So it's going to be a squared plus b squared, or if you want, x squared plus y squared. So the square root of that. So this is going to be the square root of 5 squared plus 2 squared. Okay? And so that's going to equal the square root of 29. And then likewise, the magnitude of v2 is going to be the square root of 3 squared plus 7 squared. So 3 squared plus 7 squared. And this is going to give me 9 plus 49, which is 58. So it's going to be the square root of 58. So now I've got the two magnitudes. So now I can put that in there. So now what is it? It's going to be, what else do I need? Do I need, yeah, let's continue on. So that means this, yeah, let's just fill this in. So this is going to be square root of 29. And this one is square root of 58. Okay, so now I'm going to erase this. Okay, now, I'm going to take this piece here. So this is equal to what? This is the dot product of these two. Well, what does that mean? It means that I'm going to take the sum of the products of the corresponding coordinates. So, the way I'm going to write this is going to be 1 over the square root of 29 times this one, which is 5, comma 2, right? Dot product with 1 over the square root of 58. And the only reason I'm doing this is so you can see how this process works, okay? You don't have to necessarily do it this way. And so the vector is 3 comma 7. Okay, now I'm going to erase the rest of this. I don't need this. So we've got everything else on the board, right? So now what I'm going to do, I'm going to distribute these. So that's going to give me, now I'm going to do my scalar multiplication. So this is going to become the dot product of 5 over the square root of 29, comma, 2 over the square root of 29. And now hopefully you can see why I did it this way. And now this is going to become 3 over the square root of 58, comma, 7 over the square root of 58. And now I'm going to use the definition of the dot product. And so now I'm going to take these two and multiply them together. And I'm going to take these two and multiply them together and add those two products. So what would that look like? It's going to look like this. It's going to be 5 over the square root of 29 times 3 over the square root of 58 plus 2 divided by the square root of 29, oops, times 7 over the square root of 58. Okay, now, let's come up here. So what do I get over here? This is going to be, okay, so these denominators are going to be the same. So 29 times 58, what's 29 times 58? Well, 20 times 58, well, that's going to be 116, so that's going to be 1160, right? 1160, and then 1160 plus 580 is 1740. 1740 minus 58, 1740 is going to be 1682. So it's going to be 1682. So the square root of 1682 is going to be the answer. Okay? For both of these. So this is going to be so 1682, so this is going to be 15 over 1682 plus 14 over the square root of 1682. And then if I add those, I'm going to get 29 over the square root of 1682. And of course, if I stick that in my calculator, what do I get? I get approximately, oh, well, you know what? I forgot. So, but this is equal to, now that this is equal to cosine of theta, right? So let's just write that. So this is equal to cosine theta. So what do I do now? Well, let's take the inverse cosine of both sides, and I get my final answer, which is theta is equal to cosine inverse of the quantity 29 divided by the square root of 1682. Now that, if I put in my calculator, that's going to give me approximately, oh, nice. That's going to give me a 45-degree angle. Awesome. So I find out that the angle between the two vectors is 45 degrees. That is cool. Okay. That's it. Have a great day.